So in this video, we are going to talk about a very important test in testing the convergence or divergence of a series. This is called divergence test. It comes from the theorem. It says if infinite series, pay attention, this series converges, then the limit of the general term of the sequence an is equal to 0. So this is a very important theorem. Actually, we use the converse of this theorem more importantly. We say that if a limit of the general term of the sequence is non-zero, we can claim that the series is divergent, because if it was convergent, then that should have been equal to 0. Let's take an example of this. Let's read question number 15 from. So the first part of the question says determine whether this is convergent. If you notice, it's written in curly braces. This means we are talking about sequence. Okay, they're asking if the general term of the sequence is convergent. They're only asking in part A to find the limit of the nth term of the sequence. Okay, we know how to find this limit. This is a simple infinity limit problem. How do you do that? You find the highest power of n in the denominator, that's 1. You divide everywhere by n. Okay, what will we have? 2 by 3 plus 1 by n. As n approaches to infinity, 1 by n approach to 0. So this limit in conclusion should be only 2 by 3. Okay, so the answer to the first part of the question would be yes, the sequence is convergent and it converges to 2 by 3. Again, very important. Here we are talking about sequence. Okay, the notation is really important here. In part B, though, they are asking about whether, summation of an. When they are talking about summation, they are talking about series, whether the series is convergent or not. Here we are going to use divergence test. Just now we said if the nth term of the sequence, so if the limit n approaches to infinity an, what is it coming to be? 2 by 3, which is not equal to 0 here, right? We see that it's 2/3. 2/3 is not equal to 0. That claims that what? The series, which is series here now, sigma 2n 3n plus 1 and from 1 to infinity. This series, again we are talking about series now, is divergent using what? Divergence test. Where is the divergence test? Divergence test is if the limit of the nth term of the sequence is non-zero, then that series, if you write the same sequence in the form of series, right, you add all the general terms with n1 to infinity, that has to be divergent. Okay, this is the main usage of divergence test. Let's do another example of this. We have this series who we want to check if it converges or diverges. The question is, this converges or diverges. Okay, let's write down the general term. The general term an is natural log of n square plus 1 by 2n square plus 1. Let's see if we can find the limit n approaches to infinity of the general term. Limit n approaches to infinity of this around infinity. The log is a continuous function, so we can actually Find the limit inside first. Highest power of n in the denominator is n square. Divide everywhere by n square. So what I'm trying to say is this limit can be written as limit n approaches to infinity of log of 1 plus 1 by n square by 2 plus 1 by n square. If n approaches to infinity, 1 by n square will approach to 0 and 1 by n square here will also approach to 0. So basically, we will be only left with log of 1 by 2, which is just a constant, okay? And clearly, this is not equal to 0. So here, again, our divergence test comes into play. If limit of the general term, limit of the general term here is coming to be half, which is non-zero, then using divergence test, we can say that our given series is divergent. So what are we going to say? N from 1 to infinity log of n square plus 1 by 2 n square plus 1, the given series diverges using the divergence test.